Okay, now we're going to make a bit of a segue to using the Laplace transform tables as opposed to the integration. But looking at the operations, say if you have functions f of t and g of t, and first of all, if we have a multiple of f of t where we have a constant a times f of t, we'll have the Laplace transform of a times f of t equal to, and you can put a on the outside where we have a times the Laplace transform of f of t. Now if we have f of t and g of t added together, now the Laplace transform of the sum of f of t and g of t can be written as the sum of the Laplace transforms of f of t and g of t. And the same thing can be done with subtraction, where we had the Laplace transform of the difference of f of t and g of t can be expressed as the difference between the Laplace transforms, where we have the Laplace transform of f of t minus the Laplace transform of g of t. However, okay, while we can separate in terms of addition and subtraction, we cannot do likewise in the case of multiplication and division. All right. And now, just looking at where we'll be able to utilize the tables, okay, and just taking what we have, and say we have taking what we have, let's say for the sine of 2t, and it says use transformations to find the Laplace transforms of the following functions. And okay, first of all, okay, if I have f of t equal to the sine of 2t, okay. All right, now what you're going to be looking at is with the table. Okay, so we have with the sine function. Okay, so you have sine of 2t, and this will be in the family of the sine of kt function. And in this case, k is going to be represented by 2. And so for the transform, we have k over s squared plus k squared. So you're looking at 2 over s squared plus 2 squared. And so in this particular case, so we have from the table, so you have the Laplace transform of the sine of 2t. Okay. Okay, so we'll end up with 2 over s squared plus 4. For the next item, okay, say we have f of t is equal to 4t. Okay, so you have a multiple of t. Okay. Now, for the Laplace transform, okay, of 4t, and since 4 is a constant, I can say that I have 4 times the Laplace transform of t. And for what we have in the case of the table, so for the Laplace transform of t, that is going to be the reciprocal of s squared so we have in the case of the end result, okay, we're going to have 4 over s squared. All right. Now, for what we're going to have in the next case, all right, so we have f of t is equal to the square root of t plus 5t squared. All right, let's go ahead and write in this case I have f of t. I'm just going to write this as t to the 1/2 plus 5 of t squared Now for the Laplace transform. All right, so I'm looking at the Laplace transform of t to the 1/2. And since 5 is a multiple, I can say that I have 5 times the Laplace transform of t squared. And now, in adopting what we have for t to the 1/2 as well as t squared, so we have for non-integer powers, okay, so we have t to the a, have the gamma of a plus 1 over s to the a plus 1, and for integer powers t to the n, I have n factorial all over s to the m plus 1. And so in taking what we have now, so we have gamma of 1/2 plus 1 all over s to the 1/2 plus 1. And for t squared, we have, in this case, right, so we have with n factorial, this would be 2 factorial all over s to the 2 plus 1. All right. And for what we have situated, so 2 factorial is going to be at 2, s to the 2 plus 1. Okay, so that's going to be s to the third. Now, for what we have in the layout, okay, for gamma of 3/2, okay, that is going to be the square root of pi over 2. I can just leave the square root of pi in the numerator and say I have over 2 times s to the 3/2. And I have 5 times 2 is 10 all over s to the third. And you could technically tie these terms together into one expression, but we'll just keep them separated. All right. For what we have, the next item, we have sine of 2t times the cosine of 2t. Now, we cannot multiply the Laplace transform as sine and cosine of 2t, but what I can do, we have with our double angle formula, we can say that in this case we have sine of 2t, cosine of 2t. This would be half of the sine of 4t. Remember, sine of 2t is equal to 2 times sine of t cosine of t. And just, okay, so this time, okay, have half the sine of t is equal to sine of t cosine of t, but projecting 2t out to 4t and then t out to 2t, this is what we have in the relation. So we have, in the case of the Laplace transform, you see I have 1/2 of the Laplace transform of the sine of 4t. So going back to what we have in the table, so we have with the sine of kt, have 4 over s squared plus 4 squared. Here we can reduce, okay, half of 4 is going to be at 2. And we have, in terms of the final outcome, this would be 2 over s squared plus 16. And for what we have in the In the next item, so we have, looking at, so we have the sine of 3t minus the cosine of 3t. Okay, and we can take the difference of these Laplace transforms. So for what we're going to have here, okay, so we have the Laplace transform of the sine of 3t minus the Laplace transform of the cosine of 3t. And again, so you have sine of 3t, this would be 3 over s squared plus 3t squared. Now, in the case of the cosine of 3t, this being the cosine of kt family, so this would be s over s squared plus k squared with k at 3. So, you have minus s all over s squared plus 3 squared, and I can condense into one expression. So I have 3 minus s all over s squared plus 9, and that will be the result in this one. Okay. Now, say we have in the last of this particular set. All right. So here we have f of t is equal to 1 plus 2t quantity squared. Okay, so in this particular case, if I have 1 plus 2t quantity squared, and I can write this in expanded form. So we have 1 plus 4t plus 4t squared. And for the Laplace transform, okay, so we have in this particular case, right, so I can add together. So you have the Laplace transform of 1 plus 4 times the Laplace transform of t. And I have plus 4 times the Laplace transform of t squared. And putting all together. Okay, so Laplace transform of 1, this would be 1 over s. That of t, okay, that is going to be 4 times 1 over s squared. And for t squared again, that's going to be 2 factorial, which would be 2. We have over s to the 2 plus 1, and we can consolidate also in case we have 1 over s plus 4 over s squared, and got 4 times 2 is 8 over s to the third. And putting it in terms of the least common denominator, which we have at s cubed, so I have s squared over s cubed plus 4s over s cubed plus 8 over s cubed. And if I consolidate, we're going to end up at s squared plus 4s plus 8 all over s to the third.